Hi, in this video, we are going to show you how to reverse engineer the compressor wheel from a turbocharger in QuickSurface reverse engineering software. First, we're going to go over the QuickSurface toolkits in the 2024 version and note the differences from the previous version. Looking at the top navigation bar, it looks exactly the same, but each feature has been compiled according to its respective workspace, so you can easily understand the thematics and what you need to do. And when you look at the left side, we see two panels that will make your work more effective. The top panel represents the objects on the screen, which are organized into categories, and the bottom represents the feature tree on the modeling process. Well, that's it for introduction. Let's start reverse engineering this turbocharger. Open up the STL file of the turbine reel that you can get from your 3D scatter. Once it's open, we can examine the scan data to see what we need to fix in the file and map out the reverse engineering process. The position of the STL file is not aligned with the coordinate system on this workspace, because I forgot to do this in the scan software. So we need to realign the scan data to this software's coordinate system first. Let's start by creating a few references for the aligning process. First, I will create a plane at the top of the object, which will serve as a planar reference for an XY plane. Then, I will create a reference to determine the origin. I want the origin in the center of the object, so I will create a circle section sketch as a reference and use its center as the origin. I still need one more reference to map the X or Y axis. I'll use the section sketch again and extract a line from one of the edges. Now I have three references. Next, I'll select the Align by Coordinate System command in the main menu. Select the plane as the primary feature. Select the center on the circle in the sketch for the secondary feature. Then select the sketch as a tertiary feature to determine the direction of the X or Y axis. And click Apply. We can see from the view options that the object's position is aligned to the coordinate system. Awesome. Now we can start the design process. First, let's create the main body of the compressor wheel. We are going to use the 2D sketch commands to take a reference shape from the object. The Form Revolve Surface tool is perfect for getting this revolved surface sketch. Choose an area that has a good scanned surface and that has enough features to represent the overall shape of the object. Then click Create to accept and create this section sketch. Next, we're going to use the Extract Primitive command to create a line or sketch based on the intersection results. I will take several arrows as a reference, and I'm going to add constraints to the sketch if necessary. I want to ignore the threaded part first, because I want to make this at the end. Then I will connect the lines formed with the corner trim feature. Using this feature is really easy. We just have to select the two lines that will be connected. For this area, I will use the autofill commands so that the line formed will adjust directly to the scan data. We just need to make this sketch into a closed loop now and delete any unnecessary lines. Then we can use the revolve commands on this closed sketch. Let's run the compare analysis tool to find out the deviation from the 3D model that we just created. It looks like this model is really good. At 0.1mm tolerance, it shows all green. Now we can work on creating the blades, which we're going to use the Fit Surface tool for. It's going to ask us to determine the area to be created. We would choose an area that has a good scanned surface, so that the resultant surface is smooth. Once you create the surface, we're going to expand the selection by 70% to make it easier on us later on. Check the analysis box to see how the surface created deviates from the scan data. Next, we're going to repeat the same process to create a surface on the other side. We are creating two surfaces, which we will use as a cut-in tool. We are going to cut from a revolved sketch of the blade. Run this 2D sketch tool again, and this time select Outline Mesh to get an outline of the blade. The sketch feature on QUICKSURFACE is very powerful and very easy to use, so the process is carried out efficiently. When I start making this sketch, I won't make it too precise. I'm just going to show you how the process works. Here, I'm going to make the inner part of the blade. Make sure that this part overlaps the main body so that we can combine the two solids together. Right-click to run the revolve commands, and make sure it intersects with the blade surface that we created previously. Select all objects and run the Trim tool. Then delete the surfaces that are not needed. If we run this process correctly, a solid body like this will form, and it will tell us on the top of the screen that this is a solid body. Always check with the Compare Analysis tool after creating a 3D model to see how it deviates from the scan area. It shows that it's all green with a 0.1 millimeter tolerance, so this 3D model is great. Next, we're going to carry out a circular pattern process on the blade. Select the 3D blade, then select the Circular Pattern tool on the main menu. Select the axis to be used and determine the number of instances to be created, which for this compressor wheel is 13. Repeat the Compare Analysis tool, and we can see that the resulting deviation here is very good. Next, we want to carry out the combining process between the compressor body and the blades. We're going to use the same method of doing the 2D sketch to draw out the shape of the nuts, and then we're going to extrude it. We often use this command in the reverse engineer workflow, especially for objects that have a prismatic shape. The results in 3D model that is created through this process can be easily measured, and the history/Petri tree can be shared with your CAD software, such as SolidWorks, Inventor, or Fusion 360. From this pattern created, we can see that the aligning process that we did at the very beginning is very accurate. Then carry out the extrude process on the sketch created. Use the snapping feature so that the height of the object we create matches the standard. I forgot to make a hole in the center of the nuts. But don't worry, we only need to right-click the sketch and edit it. Add a circle in the middle of the sketch and make the size larger than the intersection results. We want to make sure that the inside of the nut does not overlap the compressor body. I think this is good enough, and the deviation analysis also shows good results. Now to the last part, which is creating the threads from the compressor wheel. I'm going to hide part of the mesh first, so that I can see the inside of the threads more clearly. Select Edit Scan and highlight the area that we want to hide. Then click the Hide Selected icon. To create the thread path, we will use the Helix tool in the Surfacing tab/menu. First, we determine the axis. We can also measure the pitch of the thread by clicking Measure Pitch, then select the pitch of the thread. And we can see that the QUICKSURFACE software will provide an estimate of the pitched size of the thread. Then we will determine the starts and endpoints of the thread path. Make sure that the point we choose is correct and try to be in the middle of the profile. Determine the orientation of the thread path. I will use a counterclockwise path for this one. We can auto-adjust the thread pitch. Then the software will recalculate the appropriate pitch length. Extend the thread path on the start and end points, and choose the natural type for both. Then change the value to 100%. Next, we will create a profile from the thread using a 2D sketch. You can either create a sketch according to the thread standards, or you can extract according to the interception. Just make sure that the sketch you create is a closed loop. Now we have the path and the thread profile. Next, you want to select the suite commands from the Surfacing drop-down menu. Check Solid, then click the path and select the thread profile. Run the deviation analysis on the thread we just created. The results were pretty good, but I think I want to make a slight adjustment to a thread pitch. So I'm going to select the helix under the history tree and make these adjustments. Next, we want to create a surface or a solid to cut the threads that are not needed. So I'm going to use the 3D sketch tool again. And I'm going to take out the chamfered area of the thread. Because I will use this as a chamfer, I will make the angle 45 degrees. And I just need to make sure that this sketch overlaps the turbine body. Now I'm going to combine the body, the nuts, and the thread together. So I created a surface earlier, but it seems to me that it's going to be easier if I cut the thread using a solid body. So I'm going to edit the sketch so that it can become a solid body by closing the sketch. Okay, now to carry out the cutting process. First, click on the turbine body, then a cutting command will appear around the 3D model. Click the cut commands, then select the cutting tool to use. And done. We successfully reverse engineered a compressor wheel from the turbocharger in just half an hour. Wasn't that easy and fun? Let's run the compare tool again to analyze the deviation from the scan data. And I'm also going to touch up a few areas by adding fillets. I hope you guys enjoyed this video. If you'd like to learn more about QUICKSURFACE or 3D scanning, please visit our website at 3dwonders.shop. We have a ton of material to help you figure out which 3D scanner is best for you and the software that will help accomplish your goals.